My name is Jamie Oates and I'm your host during this training. In the previous videos, we began with the OSI model and the very first layer, or layer 1, the physical layer. Layer 2 of the OSI model is the data link layer. The data link layer is responsible for maintaining the connection or data link between two computers, which are typically called hosts or nodes on a network. The data link layer also manages and defines the ordering of bits to and from packets. Frames contain data arranged in an organized manner, which provide a consistent method of sending data bits across the medium. This kind of control is required, as otherwise the data would be sent in random sizes and configurations, meaning that the data would be understood only by the sending computer. The receiver wouldn't be able to decode the resulting message. The data link layer also manages the physical addressing and synchronization of the data packets, which ensuring an organized and stable transfer of data packets on the network. The data link layer is also responsible for flow control and error notification on the physical layer. Flow control provides the process of managing the timings of sending and receiving data so that it doesn't exceed the capacity, speed, or memory of the actual physical connection. It also receives and manages error messaging which are related to the delivery of packets on the network. The network devices which operate at this layer include layer 2 switches, which decrease network congestion by sending out data only on the port that the designated computer is attached to, instead of sending it out on all ports. Bridges, which are also layer 2 devices, provide a way to segment a network into two parts and then filter the traffic. What bridges do is they build tables which define where computers are located on which side of the bridge, all based on their MAC address. The data link layer is divided into two sublayers, the LLC sublayer and the MAC sublayer. The MAC sublayer provides access control for the transmission medium. It is responsible for moving data packets from one network card to another. This can be across a shared medium, such as an Ethernet or fiber optic cable. The MAC sublayer is also responsible for the physical addressing. Every network chip has a unique MAC address, which provides its identification on the network. The MAC address is usually burned into the memory chip of the networking device or network card. Each manufacturer of network cards has their own unique set of MAC addresses, so that theoretically every networking device has a unique MAC address assigned and burned. MAC also refers to the method which is used to allocate network access to computers while connected on a network, while preventing them from transmitting at the same time and causing data collisions on the network. The LLC sublayer, or logical link control sublayer, provides the real logic for the data link. It controls the synchronization, the flow control, and error checking functions of the data link layer for all frames and data packets. The LLC sublayer also manages connection-oriented transmissions, with connectionless services also possible. A Class 1 LLC provides connectionless only, where Class 2 can handle either connectionless or connection-oriented operations. With connection-oriented communication, each LLC frame sent from a networking device is acknowledged. The LLC sublayer at the receiving end keeps up with the LLC frames it receives, which are also called protocol data units or PDUs. If the LLC sublayer detects that a single frame has been lost during transmission, it will send a request to the sending computer to restart the transmission over again, starting with the PDU that never arrived. The LLC sublayer sits above the MAC sublayer. It acts as a liaison between the upper layers and the protocols that operate at the MAC sublayer. Link addressing, sequencing, and definition of access points all take place at this layer. In the next video, we will take a look at the network layer, which is layer 3 of the OSI model.